Hello, everyone. Good afternoon or good evening for people who have joined from different parts of the world. Just a quick sound check and mic check. If you can hear me, just give me a shout out in the chat window saying you can hear me, or just put a number one so that I know that you can hear me and we can get started. So, while we are doing the sound check and making sure we have audio and video working fine, let us see who we have on the channel. Do we have somebody who has joined in the channel? No, apparently not. I see only one person who has joined. Can you hear me? Can you hear me clearly? If you can hear me, just give me a shout out on the chat window. You can say hi, hello, anything, or just press the number one so that I can hear you. So let us wait for a couple of minutes so that the people can join. So we have got a couple of people at least. Okay, I see that at least three, four people have joined and they can hear me as well. Fantastic, fantastic. Thank you very much for joining and taking some time off your Friday evening to spend it with us and learn something new and interesting. As usual, we are continuing on our journey along API design and API performance and API security. I have plan something really interesting and cool which you can also participate. You can also try it from your console and go ahead and do that. So it's been a couple of minutes, I guess, so let us go ahead and get started, and we will see if other people are joining. We can just recap at the end and see how we can gather along and move forward. So the session topic that is for today that we are going to discuss is API design for high performance, and we are going to talk about caching your APIs, how to manage your latency, how to optimize your cost. If you have not done any of these things, you don't have to worry about it. We will cover a little bit of basics on these topics in particular, and then we'll go ahead and see how we can do that. So before we go ahead and dive deep a little bit into what it is, let us introduce myself. I'm Kumar here. I'm a solutions architect. If you have been following this channel, or if you have been watching my videos in YouTube, you might be familiar with my style of work, or what I've been contributing to the community in YouTube. I've also created some structured learning courses in AWS, particularly in security and automation. The links for them should be in the description. And quite a lot of the automation today that I'm doing is based on AWS Cloud Development Kit, and the course for that also should be in Udemy as well as in the description link. And finally, most of the code that I show you guys today and in the previous webinars, all of them are available in my GitHub profile. You can go ahead and fork them, you can star them. If there is a bug, send me a pull request. I'm happy to incorporate them. Or if you're collaborating on something or creating something and you would like to work with me or get my opinion, send me a comment or an issue or assign it to me in GitHub. Then I can take a look and help you with that also. So that is about me. Let us talk about this particular session. So this session is going to be an intermediate level in AWS. What I mean by that is we are going to assume that you already know something in AWS. Either you are working on it or you're already learned a few things. You know how to create an EC2 instance or log into an AWS console, or do things like creating auto scaling, or you know what is a monitoring service, or how to do an IAM roles, things like that. So we are not going to cover pretty much basic. So while we are doing this, in the chat window, a question for everybody, let us say just a poll. If you are working already in AWS, go ahead and type 2 and let us see how many people are already working in AWS. And if you are new to AWS, and if you're just starting out or beginning, then go ahead and type 1 so that we know what is the type of audience that we have on the stream, so that I can adjust the content while along, and maybe I can add some context on certain topics while we are looking into the section webinar itself. So that's 4 or 5 people who are already working in AWS. So there is somebody new there, a couple of people. Yep. So we have quite a good mix of people who are working and who are just starting out and getting there so that they can also join. Fantastic. So that is on the level of the session. And today's session is also going to be about API, particularly designing high performance API by using a couple of features that AWS offers. And we are going to do the entire automation or deployment so that we spend more time understanding the concept on not clicking on the console. So I prefer trying to walk through the features and what that features offer rather than showing where to click. So let us focus on that by using CDK automation. And if you have any questions during this session, go ahead and use the hash questions before you type in. So this has to be the prefix. And likewise, if you want us to look at some topic or some GitHub or article that you're writing, type in hash suggestions, then we will have a look into that and take it forward from there. So that is the ground rules housekeeping done. So let us dive in a little bit deeper. So if you are going to do this along with me, or you want to try it with me while I'm doing this here, you can also follow along. As I said, the description of this video will have the URL for today's session. Also, if you scroll down at the bottom, you should be able to find it. So just a bit of context. What is an API? Because we are going to talk about designing and highly performant API. So before going into doing that, what is an API? In my opinion, API is a contract between the service provider and the consumer, where the service provider says, you give me a certain input, I will process that input and give you a certain output in a certain format. And this is the endpoint. I will manage the operating system or runtime or monitoring, logging, authorization, authentication, everything. But as a consumer, you don't have to worry about all those things. You just send me an input in a particular format. So think of it as a contract between the producer and the consumer of data. So that is what a simple API means. So in a typical context, your left hand side, that is the client that you see here, is going to be your consumer, and the consumer is going to send a request to your API server. So what happens behind this API server does not need to be known to the client. So it is completely transparent or opaque depending upon how you want to implement your API. So in this case, what happens is the API is going to talk to your backend server and then maybe a database to fetch some data and send your response back to your client. So the left hand side from the client to the API is the contract part, where you send a request and get a response. And as a developer or as an application owner, you take care of the things that are on the right hand side. So when you want to deploy this or use this in AWS, so what happens is, instead of a database, you can use a NoSQL database like Amazon DynamoDB. There is nothing wrong in using something like RDS or SQL database, but we are going to talk about a very simple use case today. So I'm going to use a DynamoDB as a data store. And when it comes to web server, I am going to run my web server in Lambda functions. So any request that is coming in from my API server is going to hit my Lambda function, and the Lambda function will decide whether we need to talk to the data store, or we can just send the response back without processing the request. And for API server, we are going to use the Amazon API gateway. So this is going to be the architecture that we are going to use today. So this is the typical architecture, right? So what is the problem with it? So let us take a simple use case. For example, you are watching a cricket match. If a lot of people are from India, let us say you're watching an IPL or a match, then you would want to know the latest score from your web browser or your mobile device. And the score, as you know, it is constantly changing with every event. Maybe a new ball has been bowled, or there is another event. If you take another match like a football, you want to know what is this latest score. So each sporting event will have a different kind of an update mechanism, and a lot of people will want the scores. And if you think of a country like India, we will have millions of users trying to hit that website to get the latest score. But any given point in time, the score is going to be constant. So basically, millions of requests is going to get the same answer at the same point in time. When the score changes, then the website gets updated. then all the refreshed data has to be pushed back to the end user. So what happens is when your millions of requests coming, obviously your backend server is going to get overloaded and it is going to take more time to process the request. So basically what happens is you send the request to the server and the whole traffic is going to be blocked because there is so many people accessing the same information. So let us say it is going to take about 105 milliseconds. So your backend server is processing the information and wants to push back all this data back to each and every user. And this is going to be, let us say, because we are doing some processing, we are checking the database for the latest score and then pushing that information back to the client. It just takes about, let us say, 1.3 milliseconds. I'm sorry, 1.3 seconds, about 1300 seconds. So in total, as an end user, you will have 1.5 seconds before you get a response. Basically, nobody likes to wait today. If you are watching a cricket match and you are getting a response which is slower than 1.5 seconds or 2 seconds, by the time something would have happened on the field, then you are getting an information slower than other people. This is not the best user experience. Your users will move from your website to some other website where they can get the response much earlier. Let us say another website is giving you a score update which is just half a millisecond delay. Then users are going to go to that website, which is very common, right? You want to be connected with the event as soon as it happens. Nobody wants to wait until the event has happened. So this is what we want to reduce. We want to reduce our latency as much as possible, so that our users are having stickiness to our web service and they continue to use our web service, and you want to grow beyond that. So how do we do this? How do we reduce this latency in AWS? So earlier we saw this is the architecture that we are using. We have our clients on the left hand side, we have API gateway and Lambda and DynamoDB where the scores are. So the one way to do this is caching your requests or caching your data so that all the requests does not hit your database. So typically what happens is an API gateway offers a feature called as a gateway cache, and particularly useful when you are having millions of requests coming in and you want to store them so that all the requests can be handled by the API gateway itself and doesn't have to go to the Lambda. So how does this work? So let us say a new request is coming from your client from the left hand side. So what API gateway does is it is going to check your cache first. So you say, give me the movie of latest movie that is available or top 10 movies. So API gateway will check your cache. Do I have a list of top 10 movies for today? Then if the cache is there, then the response will be sent back to your client, and the flow is not going to hit your Lambda function and it is not going to hit your DynamoDB also. So there are two benefits here. Because the call is not going to two other services, you are going to reduce your response time, and likewise you are also going to reduce your cost because you are not invoking your Lambda and you are not running your DynamoDB also for those whenever your cache is hit. What happens when a cache is not there? For example, this is the first time somebody is asking some information and nobody has queried this information, because how cache works is the first person who hits that query will be copied to the cache also. So let us say today morning the cache has been cleaned and you are the first person querying for some information, or the match has just started and you are the first person querying for the match information, then the Lambda will be invoked, the data will be retrieved from your DynamoDB, and before sending it back to your client, a copy of the data will be stored in the cache. So that is what we call as a cache ingestion or a cache hydration. So once the cache is there, then you respond back to the client. If the cache is not there, what happens? So that is what we are going to see now. So when a cache is missed, API gateway is going to forward that request seamlessly to your backend. So in this case, the backend is going to be a Lambda function, and that Lambda function will again make a call saying, do I need to talk to the database, or can I send this process this request internally without talking to the database, so that I can save one more call. So whenever a cache miss situation happens, Lambda will make that API gateway will make the decision. Again, you have an opportunity of doing that decision in Lambda also, because Lambda also has some amount of caching, but that is not ideal for these kind of scenarios. So this is how caching helps to reduce the latency of your calls and also reduce the cost of your application when you're running it at very high scale. So as I said, we are going to do all of the things that I spoke about just now in a real life demo. I'm going to start building every piece of infrastructure that we saw on our screen right now. And if you are going to do it along with me, as I said, the code is available in GitHub, so you don't have to just listen to me and look at the screen. You can also do it along with me, because this is pretty much automated. We just need to launch the stack and wait for the stack to be deployed. So let us go to the demo, and before I go to my console and show you what we are going to do, I'm going to briefly talk about the architecture that we are going to build. So basically we are going to build two different APIs. The first API is going to be a default one. Let us call this as uncached API, meaning every time you hit the API gateway, the Lambda function will be triggered. What I've done is I have added a timestamp. Basically, whenever you send a request to the API gateway, Lambda responds with a timestamp, so that you will see every new request will have a new timestamp, that is the invocation timestamp, so that you know that a Lambda is getting invoked. But we are going to build another architecture where caching is going to be enabled. And what this means is whenever first cache load has happened, the remaining request will not go and hit my Lambda function, so the timestamp will not change. So this way we will clearly see whether I'm hitting the cache or not, or whether my Lambda function is invoked or not. And I've also added one more variable, very interesting one, which is called as a time to live, because if you take a sporting event, as I said earlier, the score changes pretty often depending upon the kind of event that we are talking about. In cricket, the score gets updated every ball or every run that is being scored. Either you have a wicket, or there is another over that has been bowled, or another run has been taken. So you have different events, so there is a different matrices that gets updated. Whereas in an event like a football, you get changed only the score when there is a goal, or there is a penalty, or some things like that. So depending upon that, you can change the TTL value. TTL is nothing but the time to live, how long your cache needs to be stored, so that people don't get old data. So in a cricket kind of scenarios, I would like to keep the TTL very, very low, so that because the score changes really fast. Whereas in a match like football, I would use a different TTL value, which is suitable for my sporting event. So in this demo, I have set a TTL as about 30 seconds. So what this means is from 0 seconds to 30 seconds, if I hit my API gateway, I will not be hitting my Lambda, I will be hitting my cache only. But on the 31st second, I will see my timestamp change, or 31st or 32nd, there is a kind of, when the client side it is very difficult to measure, but on the server side automatically the cache gets refreshed. So on the 31st or 32nd, you make another request to the API gateway, automatically it will go and invoke the Lambda function and update my timestamp and bring it back. So we will all see this in a real life script that I have done, that is also available in the GitHub, and we can do it. So once again, as I said, all this automation is done using the AWS Cloud Development Kit. If you want, you can go ahead and check that out. So I'm going to take you to my AWS console first, so that we can have a quick walkthrough of what are all the different services that we are going to use. So let us see if I can bring you to my console. Yeah, this is the GitHub page, and if you are interested in doing this on your own account, or if you want a copy of this code, go ahead and fork them. Or if you like this repository, go ahead and give a star for me, or send me a pull request, so that if there is any bug, we can fix it. So right now, I don't have any CloudFormation related to the API gateway stack. And you can see here there is only two stacks. Let us ignore these two for a moment, because this is not about the stack that we are talking. If you have been following my webinars, you will always see these two stacks in my account, because this is for a different demo that I'm building. And if I go to my API gateway, and if you, oh, I got logged out. Okay, that should not be a problem. But you notice that I am in a Virginia region, but this stack is a pretty much region agnostic. You should be able to deploy this in any region. I have tested with a couple of people, and they were able to deploy it in other regions as well. So likewise, if I refresh my screen here, I don't have any Lambda functions in Virginia. So let it load. Apparently it's taking some time. Yep, you don't have any lambda functions. So what we are going to do is we are going to see two APIs. One is going to be called as the uncached API, and another one is going to be called the cache API. So let us go back to our GitHub. So the first, if you want to follow it, what you will do basically is you will go and check out these prerequisites, and you will clone this environment locally, and then you will start deploying it. So I have done all these things to save time, and I'm going to start from step number 4, where we are going to deploy these stacks. So let me take you to my Visual Studio Code. Hopefully it should be visible now. Okay, just give me one moment. My Visual Studio Code is not sized properly, so I'm just going to take a moment to fix that. Hopefully that fixes it. Okay, so you should be able to see my Visual Studio Code in a short while, and as I said, I have already cloned my repository, and here we have in my terminal, I'm going to activate my virtual environment so that we can go ahead and deploy it. Let me just pull this up a little bit. Quick check, can you see my terminal screen, or should I increase my font size? Just to quickly say, like, it is visible, I can see it good. Anything, so that if it is not clear, I can go ahead and increase my font size. Meanwhile, I'm just going to list my stacks. So I should be able to get two stacks. One is uncached API, another one is cached API. Okay, fantastic. So this is one problem that I'm not able to fix. Probably I need to get a better machine, because usually CDK LS works really fast, but to streaming and deploying things like this is really tricky. Please increase. Okay. Okay, just give me a moment. So this is going to be a little bit of an ugly hack, I think. Settings. Yeah, font size, let us say 19. Okay, let me go all the way to 20 then. Otherwise, if there is a longer line, it is very difficult to see it as well. So I've increased a couple of points. I was at 17, now I'm at 20. So hopefully, let me just do a CDK LS. Is this any better now? Otherwise, it will be super big. So I'm looking for some feedback on the chat. If somebody confirm it's good, or you want me to increase more, then that will be helpful. So what I'm going to do now is I'm just going to deploy the uncached API first. So there is not much to see here. So at least right now, because we are just going to deploy the stack. And once the stack deployment has started, we can go back to our console and see what resources are getting built. And there is an activity for all of us. I can put in the link on the chat window, so all of you can hit that and confirm to me whether the timestamp value is changing every time you hit the URL. And there is for people who are building or working already in AWS, this is a very interesting tidbit or information that I've built into the stack itself. If you remember, when you created DynamoDB, you will get an empty database. You won't get any data inside it. But when I'm deploying this stack, that DynamoDB is going to be loaded with some data also. I am loading about 10 movies. So that is what we are going to query. So every time we hit the URL, we will get an movie data, like a movie title or movie index and a movie rating also. I just picked up some random movies from IMDb and created 10 records, so about 0 to 9. So you hit the URL, you get a new movie every time. So the ingestion of that data into DynamoDB is being completely automated. And if you're interested, go ahead and look into the code to see how it is done. Maybe if there is enough interest, we can do a separate webinar on custom Lambda, custom cloud formation configurations. So this is getting deployed. So what I'm going to do now is I'm just going to take you guys to my AWS console page so that we can see what is getting built there. Okay, so we are in a cloud formation. You can see here there is the cached API creation has been complete. And the interesting part is this is the output section and this is the URL that I'm talking about. So the first time I'm going to show you guys here on my screen so you can try it later on the chat window. I'll update it. So when I go ahead and put it into my address bar, fingers crossed, okay, it works. You can see here it randomly gives me a movie ID of 9 and it says now you see me, and this is the timestamp that I'm talking about. So if I copy this, there is no caching on this. That is why you can see here this is the address bar, this is the URL also. So let us see if I can zoom in. No, it doesn't work. So if I go ahead and copy this again and paste it into another tab, you should be able to see another timestamp here. This will be different from the previous one. So every time you hit it, you should be getting a new timestamp. Basically, that means that the Lambda function is getting hit and the response is coming back. So I think I built one more method also. Say for example, I want a particular movie. As I said, there are 10 movies. So let us say I want the 6th movie. So I can do movie/6, and if it works properly, I should be getting movie number 6 also here. Yeah, you can see here this is the ID number, which is the index of the movies, and every time you hit 6, this number will also change. So I'm going to put this URL in the chat so you guys can also hit the URL and see whether the timestamp is changing. Basically, there is no caching here. Every time my Lambda function is getting invoked, and then it goes and talks to the DynamoDB database and brings the response back. And if you use a tool like Postman, let me just go to Postman tool. Let me see if I have configured Postman to be visible on my no, not yet. So just give me one moment. I'm just going to fix this. Postman is not visible in my streaming software. Let me see if I can fix it first of all. If not, we can skip that for a moment. Okay, that should be available Postman, and under Postman what I'm going to do is I'm just going to put this URL, and you can see here it is uncached. Why I'm seeing it here is Postman gives a very nice way to check the timestamp. I can do that in CLI also. You can do the time space curl space URL, but the Postman makes it visually very interesting. It gives me a timestamp saying the status is okay, and it takes about 520 milliseconds. So you will see that when I invoke the second time, all of this will disappear, and only the few milliseconds will be there. About from 500, it should be going down to say 100 or 200, depending upon how fast my API gateway is. You can see here it is at 324 milliseconds, but still the timestamp changes. Basically, that means that I'm hitting my API plus Lambda and everything. I'm paying too much for sending the same data. So, and this is again a random write. So let me just go ahead and change it to a particular movie, say 9, and I'm going to take this and put it here also. Oh, come on. So you can see here I'm querying for the same data, and I'm spending about 310 seconds, again 410 milliseconds for each and every round trip. This is what I want to avoid. Just for sending the same data, I should not be spending so much time, and I'm paying more also. So this is what we want to avoid. So let us go ahead and deploy an cache stack. So here what I'm going to do is, if you notice, if I did CDK ls, you saw a cached stack and an uncached stack. We did one of them. I'm going to deploy the other one. Then I will take you to the console and see where is the caching configuration and what is the minute configurations that you can customize there. Also, what are the features that are available. Let us deploy this first. CDK deploy cached API. And while this is deploying, what I'm going to do is I'm just going to check in the chat if anybody else is checked and updated in the chat. So did anybody else check it on the your computer, and then did you see the timestamp change? Can you give an feedback on the comments? So this is getting deployed. So what I'm going to do is I'm going to take you to my console now. So here, if I go to CloudFormation, we should be able to see one more stack that is getting deployed, and that is the cache API. So let us go to our API gateway and see there must be two APIs now. One is, let me just filter it for, I don't know whether it will work. Yeah, it is working. So one is for uncached, another one is cached. If I go ahead and open this API is also very similar to the uncached one, but only thing is we are enabling the caching feature, so you can go ahead and compare this once you deploy it in your own accounts. So I see only one method has been deployed. So if I go to my stages, come on, I think it is still getting deployed. We need to wait a bit more time, I guess. Come on. Okay, we are almost there. So let us give it a few more moments until the deployment configuration completes. Meanwhile, I'm just going to quickly check on the chat if anybody has seen it working and given some updates. I see a couple of people who confirm that the timestamp value is changing. So now I am on my API section and I am under the stages, and just to be sure, we are at the cached API. Okay, we are at the cached API section, and under stages you will find enable caches. This is what I have done. So when I check this box, I obviously get an option to choose how much storage I want. If you remember, I am doing everything through CloudFormation. I have not configured anything. I've chosen the default value because this is a demonstration, and I don't want to incur too much cost while showing this demo. So I've chosen the least available caching capacity, which is about 0.5 gigabytes. And if you have an application which requires a lot of caching, then you can go all the way up to 237. And remember, this is per API. So if you want more caching, then you can just split your APIs into different deployments and then have more caching also. And this is the TTL value I spoke about. I have set it at 30 seconds, meaning anything that is entered into the cache will be there for 30 seconds, and after that it will automatically expire, and every new hit will get stored in the cache. So the interesting thing is, you can see here I demonstrated a slash movie, which gives you a random movie, and then a movie slash ID where you can query for a particular ID. So what I've done is I have disabled caching for this random movie so that we can clearly see how the caching works. So if I go ahead and click on this get method here, and if you see here in the bottom, enable method cache is disabled. So even although I am saying this is a cached API, the slash movie URL request will not be cached. So what it means is it gives you a very granular control for you to say within a particular API, I can cache a certain paths or certain methods like a get or a put or a post, and certain paths like slash movie slash ID. Like for example, somebody is querying for a particular match information on a particular day, then I want to cache that request. So you have really granular details. So as I showed you, this one is not having a cache, and whenever somebody requests for /movie/id, I will be caching that. So if I go ahead and click on that, you just get this default one, because by default I have enabled caching at this level, and I'm just going ahead and disabling it only for this method. So that is why this one is disabled, whereas when I go here, you just get this option. And if you want to disable that, you go ahead and say override for this method, and then you can go ahead and remove this. But if you remove this, is how it will be, but I'm not going to save it because that is what we want to demonstrate. So let us go to our stack now, pick up the URL, and remember one more important thing: when you deploy this stack, it takes about 1 to 2 minutes, or sometimes I've seen up to 3 minutes, for AWS to provision the cache and the cache to warm up, and then it will start caching your request. So if you try it right next second your URL is available here, then you will find the cache misses. Basically that means that your Lambda function will get triggered for until the cache starts warming up. So it usually the delay is about 1 or 2 minutes, but since we spent some time talking about it, hopefully we should not see cache misses. So this URL, this is /movie, which is going to give me a random movie, is not having any cache enabled. So every time I press enter or refresh my screen, I should see the timestamp change. So let us go ahead and try it again in another tab probably, so that we can compare it easily. So you can see here this one is having something like 560, and this guy is having 302, and likewise you see this is a movie ID 8, and this one is a movie ID of 0. And if I go ahead and try one more time, I should be getting a different movie with a different timestamp. So what I'm going to demonstrate now is how caching really works. So let us go ahead and query for, say for example, a movie number 5. So this ID for me should change to 5, and any subsequent request for movie 5 should have this same timestamp. So fingers crossed, this is what we have been building for last 15 minutes. So let us see whether that works. So this is just going to copy this timestamp and see if my cache has warmed up. Okay, Control F is apparently not working, but you can see here this is the same timestamp here. So let me make this into raw, probably that will work. Yeah, because I have a plugin which shows my JSON value as a very readable format, so it shows like this, and searching for the same timestamp looks slightly odd. So but anyway, you can see this is the same timestamp that you get from here. What I'm going to do now is I'm going to put this URL into the browser chat window, so that you guys can also try it out. Remember, the movie is a random one, and if you do movie say 8 or 9, 0 to 9, you can give anything. You should not see the timestamp change. So I'm going to give a couple of minutes for you guys to try it out. In the meantime, I'm going to set up a script which can query for 30 seconds continuously until the cache gets refreshed. So that is what I'm going to do now, and the script is also available in the GitHub article. So that is what I'm going to set up right now. So let me just copy this. Meanwhile, if a couple of people can confirm on the chat window, that would be really helpful if it works as expected. So copy this. Let us go to our terminal, and I also need the URL, so I can take this URL. This is the cached API URL. Copy this, and I'm just going to replace this one. So what this is going to do is I'm going to run it for 31 seconds, and it is going to just do a curl of that URL, and it is going to show it on my screen. So let me clear my screen. Let me just make it all the way up. Copy this and then just paste it. So you can see here constantly it's hitting my URL, and once it's complete, let me talk about it. So if you can read it, it's really tricky, but if you can read it, you can see the timestamp is constantly the same. That means that my API is responding from the cache And I'm also echoing the timestamp for every request that is made. You can see after about 31 seconds, we will be able to see the timestamp change. So we got our response. So it's going to be really tricky to explain here, but let me try my best. So you can see here, this is the first request that we made, and this is the timestamp that came from the server. And if you just keep a track of this number and scroll down, almost all the requests that was made to the server was with the same timestamp, like this 2996, and almost the last one, you can see here, this one was 2996, the last one was 965,189. Basically, by this time it was about 31 seconds, and the cache got refreshed, and the new request was made to Lambda, and that cache entry was made into the cache storage, and that was returned back to me with a new timestamp. So for the next 31 seconds, this will be your timestamp, and after that, it gets constantly refreshed and gets updated. Of course, it is not only you should wait for Lambda to refresh it. You can also manually invalidate and cache. That is also possible. You can do some automation whenever your data store gets a new value. You can ingest it and do a cache invalidation, and automation is also possible for that. So this is basically that I wanted to demonstrate to you guys. What I've done also is, if I take you to my GitHub page, I did some load testing on my API. Basically, I did some automation so that I throw some 50,000 requests at my server for a considerable amount of time and at different periods. So you can see here, this is the cache hit. So I was just throwing about 200 requests per second, and I did it for about an hour. And then another period, I did another hour. So it was like close to about 15 to 20,000 requests. So you can clearly see there is a cache hit count and cache miss count, and you can see the drop and then increase. So basically, and there is another graph here. This is what the most interesting one, the latency graph. That's what I wanted to start with actually. So the orange color line that you can see here, this is the uncached latency. So when you don't have a caching in your application and requests are flowing in at that rate, 20,000 or millions, you can see here, this is in milliseconds, by the way. So we are talking about 350 milliseconds of response time, whereas this blue color line, which is about caching of your API, which is a response time of about 210 probably, or something like that, 210 milliseconds. So you have a huge performance difference when you have caching and when you don't have caching. And not only just caching, performance important, you also notice that the Lambda function is not getting invoked. Your DynamoDB is not getting invoked. If you remember AWS costing dimensions, you are paying for every invocation of your Lambda function. And in DynamoDB also, you are paying for every read of your DynamoDB. So you're avoiding that, and you're saving cost as well. So it is not just good performance for your users, it is also very cost conscious and very frugal engineering, in my opinion. So since we are pretty much early and completed, if you have any questions right now for the demo that you have shown or something similar, I am happy to answer them. Put them in the chat using the hash questions prefix so that I can easily pick it up and answer them. Or if you have a suggestion that you want us to look at, then we can do that as well. Or if you're having some doubts or something is unclear in what I have shown, we can discuss about that as well. So I'm just going to grab some water while you guys pick up something. So this is the questions time. If you have anything, so I'm just going to switch my screens and then have a look at the chat window to see what questions have come up with. So, Mr. Suraj DevOps, thank you for being a patron to join all our live streams. I really appreciate people coming up and taking 1.5 hours of our personal time to look at these kind of things. So, I really appreciate it. I see some regular names. I'm really happy about it. So, let me read your question now. Can you do a video on how CloudWatch Synthetics do AWS API endpoint health check? And what is the difference between CloudWatch Synthetic and X-ray services? Um, okay, for X-ray, there is already a complete automation in my GitHub. You can check it out. That is pretty much an advanced topic. You need to know a little bit on development experience also to understand, to take the advantage of X-rays. So I will consider that as an suggestion and see if I can do an webinar on that. Coming to CloudWatch Synthetics, maybe in the API series that we are doing now, probably we can do a session on logging so that we can see if synthetics can be covered there. Thanks for the suggestion. I'll take it into consideration. So, just another question from Mr. Sujit Sharma. How post request will be managed in API REST API cached? Yeah, it is possible. That is why there are many places where you can do caching in a serverless architecture. If you're deploying the API in an edge configuration, then you can cache it at the CloudFront level. But that does not give you to cache post methods. You can only cache get methods in CloudFront. But when you enable caching in API gateway, the benefit is you can do post method caching also. It works in the same way, right? For example, somebody just let us take a simple post method of like you have a video and then somebody goes ahead and adds and like to that video. So that information is very much public, so you can easily cache that information and see how we can, and that will not be the best example. Let us talk about something else. If nothing pops up into my head right away, but if it comes up, I'll update you. But it is definitely possible to cache post methods also in API gateway. So that is one of the reasons this feature is available. And there is a question from Lakshmi Prasanna. Hash question: how to understand the JSON format easily? I'm new to AWS. Well, you can just Google for Chrome plugin for JSON, so that if automatically the plugin will do that. It's basically a Python key value dictionary or a map in some other languages. So it's once you get a hang of what is the key value pair. Let me see if I can show that on my screen. Just give me one moment. So I'm just going to take an example of this. This is a JSON value, right? You can just fold it. This is one easy thing that I do. If there are too many variables, I just keep folding them until the root level, and then I just go and unfold them, saying this is the key and this is the value. And in JSON, all the values have to be wrapped in quotations. It's just JSON notation. There is no other way you can go about it. So, and you will have an parenthesis at the opening at the end. So but I really like this plugin. I forgot that, but this is a common plugin. You can use any of them. There are many of them. You just go ahead and write Chrome JSON plugin, which will take a response which looks really ugly to read like this. But once you have the plugin enabled, automatically the plugin just goes ahead and does the formatting for you. And you can also go ahead and search for something like a JSON editor online. There are many editors online. So if you just go ahead and take this ugly looking string and put it into this let us say this editor, and then say if it is the syntax is correct, then automatically it will parse it and it will give you a nice view. So that is one nice nifty tool, but you can do this in any editor. I'm just giving you an easy browser based mechanism, but basically it should be the same. So let me just go back to the chat section again and see if we have any other questions that are coming up. Mr. David Bialy says, thank you. Yep, appreciated. Appreciate your time. Mr. Krishna, there is a question. Can we configure AWS API in multi-VPC environments? So I am still not very clear on this question. You want to deploy the same API in multiple VPCs, or you want to access the same API which is deployed in one account in multiple VPCs? So either ways it is possible. There are ways to do that, but you need to take different approaches, because unless you do a private API, your API is not bound to one VPC. It is bound to that account. So it is not dependent on your VPC unless you do private endpoint deployments. So let me see if there are any questions. If there is a follow-up on that question, I guess, if I remember correctly, your APIs are being charged for, API gateway is being charged for the number of requests that is processed by the API gateway itself. So if you are deploying, accessing it from multiple API, multiple VPCs, basically it is like how many requests that you are processing. That is the most important question that we need to answer. And do we need to really put it into a private endpoint so that it is accessible from an VPC, because you have additional restrictions like VPC or IP addresses or resource policies. So those are the considerations that I would start to with, instead of looking at pricing as against multiple VPCs. Again, for your question on availability, let me think. Because as I said, API is not managed by you. Amazon offers you as a service, and if you are looking for high availability, Amazon manages it for a particular region, right? So if you want a multi-region deployment, then that is up to you how you are routing your request between the same APIs which are in multiple regions. So availability on a region is taken care for you, highly available by default by using API Gateway, because it's a managed service and Amazon manages it for you. So if you are looking for any questions, once again, I just recommend you to go ahead and add hash questions before your question, so that I can easily pick it up. Otherwise, it is pretty difficult and my filter doesn't highlight your questions. So if you want me, or if I have missed any of your question, or if I have missed any of your suggestions, please use hash questions or hash suggestions in your question, so that it is easy for me and easy for you as well. Okay, I see a suggestion that is popping up. Lakshmi Prasanna. If you go to my Udemy profile, you will find an CloudFormation course available free of cost. You can spend as much time as you want. There is a 1.5 hours of course, and the YouTube channel that we have has plenty of CloudFormation courses. At least 5 to 6 hours of CloudFormation content is available. So it is just a search away. So I would say you have enough information in that aspect. Almost all of them done by me, and some of them are done by my partner. So you should be having enough information to get you started with CloudFormation. Okay, I see another question from Mr. Shekhar Soma. If caching is enabled, there is less chance of throttling. Well, throttling is at the API level, right? So you are still hitting your API. So caching reduces your calls to your backend. So you will still get throttled. But if you're doing caching at say something like CloudFront, then the throttling is a different question, because CloudFront you're paying at a different level. You're not paying per request. So That is my take on that. If there is somebody else who has a different opinion, I'm happy to learn from that. So let me quickly see if there is, just going to quickly check API gateway pricing here. Meanwhile, this is your opportunity for any questions that you might have, then I can answer them. So the first for REST APIs, it is about 333 million is about $3.5. 333 million calls or requests you are paying about $3 to $4, and about 0.02 dollars for zero point 0.5 gigabyte of caching. So it's pretty much like $4 you pay for 300 million calls. Okay, fantastic. So the one more thing that I wanted to talk to you guys is if you have any suggestions, because we are already prepared for our next weekend session also on API Gateway. If you have any suggestions on what we should be looking at in the coming future, put them in the comments of this video, and we will process them and do it. Uh, Another thing is, if you like or if you want to contribute to my GitHub article, go ahead and send me a pull request. I would be really happy to work with or collaborate with you guys. Or if you're writing some automation, I can also have a look and learn from that also. And if there are no questions coming up, we can wind up early as well. So one last question I'll take, because there's something I see on the screen. API request can be cached with authorization. Yes, you can cache your authorizations as well. It is possible. It requires a little bit of additional work on where you are storing, what kind of methods you can do, but it is possible to do that. Because let us say weather forecast, this is a nice example. uh, for free tier, let us say you are offering weather forecast, not forecast, weather for today. Like today you are saying this city is having this much temperature, but somebody is authorized or a premium API user, then you can give him or her a forecast for tomorrow also. And there might be, let us say, multiple users who might be in the premium category. So you want to do a forecast for all of them, then it is possible to cache those authorized request to your backend also. So it is possible to cache your authorized API request. So depending upon what is your application, what is your flow, and what kind of data you have, and then yes, you can do it for quite a lot of use cases, and there might not be some use cases possible, because always edge cases are there. So you can do caching for authorized request as well. Fantastic. Then we will wind up for today. Once again, thank you very much for spending your Friday evening with us. We will see you in the next webinar then. Until then, thank you very much. Have a nice evening.